Look up at the night sky. See all those twinkling stars? Ever wondered where they come from? Stars like us have a life story. They are born, they shine, and eventually they fade away. Their birthplace? Giant clouds of gas and dust called nebulas. Think of them as cosmic playpens where baby stars are born. These nebulas are spread across the vast universe, each one holding the potential for countless stars to ignite. These nebulas are not just random clouds, they are made up of hydrogen, helium, and a sprinkle of other elements. These elements are the building blocks of stars. Drifting around in these nebulas are tiny particles of dust. Imagine these dust particles as ingredients waiting to be combined into a cosmic recipe. And what's the chef that brings these ingredients together? It's the force of gravity. Gravity is a bit like an invisible dance instructor in the vastness of space. It pulls things together. In a nebula, gravity starts to gather the gas and dust particles. As more and more particles come together, they clump up, forming a dense core. This clumping also leads to collisions, which generate heat. The core starts to heat up, like a snowball rolling down a hill, gathering more snow and momentum as it goes. As the core gets denser and hotter, it becomes what astronomers call a protostar. Think of a protostar as a star in the making, still gathering mass and heating up. It's not quite a star yet, but it's well on its way. The protostar is a hungry, growing entity. It continues to pull in gas and dust from its surroundings, getting bigger and hotter. As it gets more massive, its gravitational pull gets stronger, attracting even more material. This process can go on for thousands of years. The protostar is like a cosmic vacuum cleaner, sucking up everything in its vicinity. But here's the catch. All that infalling material creates a lot of pressure at the protostar's core. As the pressure increases, the temperature at the core skyrockets. Things are heating up in the protostar's world. The protostar is glowing brightly, radiating energy into space. But it's not yet a true star. For that to happen, something even more spectacular needs to occur. Deep inside the heart of the protostar, something amazing is about to happen. The temperature and pressure at the core becomes so intense that hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse together. This process is called nuclear fusion. Nuclear fusion is like a cosmic power plant. When hydrogen atoms fuse, they create helium and release an enormous amount of energy. This energy is what makes the star shine. The outward pressure from the energy released by fusion balances the inward pull of gravity. This balance is what makes a star stable. The protostar has finally come of age. It is now a main sequence star, shining brightly and steadily, powered by the nuclear fusion in its core. Not all stars are created equal. The fate of a star depends on its mass. Small stars, like our sun, will live for billions of years, slowly burning their hydrogen fuel. They eventually become white dwarfs, small, dense remnants of their former selves. Massive stars, on the other hand, live fast and die young. They burn through their fuel much faster and explode as spectacular supernovas, seeding the universe with heavy elements. The remnants of these supernovas can become neutron stars or even black holes. The universe is a vast and wondrous place, full of stars in various stages of their lives. From the birth of a star in a nebula to its eventual demise, the life cycle of a star is a story of cosmic proportions. So the next time you look up at the night sky, remember the incredible journey these stars have taken and continue to take, lighting up our universe.